So today we're going to be talking about the line of best fit when we are using scatter plots. So scatter plots are useful for real world situations. They kind of put our data that we've collected onto a coordinate plane. So those aren't going to be perfect all the time. So we're going to try to find a line of best fit for those scatter plots. So when analyzing a linear scatter plot, remember linear means a straight line. This is the line that travels through the middle of the points the closest. So it's not going to go through every single point, but it's going to be towards the middle of most of the points on our scatter plot. Slope, we've talked about this multiple times. It's just the steepness of the line. It's our rate of change, and we put our rise, how far up or down, over our run, how far left or right. So, and then we have our y-intercept. Again, we've talked about this multiple times. This is the initial value of a situation, the starting point where the graph intersects the y-axis. So that's our vocab, just going back over slope, y-intercept so that we can get to that line of best fit. So talking about line of best fit, scatter plots are usually used to display real world data, which does not usually follow a pattern. Mathematicians have decided that there is a linear trend. Remember, that means straight line, that they usually go in kind of a straight line. They can approximate the average of the points by drawing a line through the middle of the main trend. They do not consider outliers. So remember, an outlier is a point or a piece of data that's way far out, way too big, or way too small. So we do not consider those when we're doing our line of best fit. So don't try to move the line for the outlier. After they identify a reasonable line for the data, they calculate the slope and the y-intercept of the line itself. So once we draw that line, we're not looking at the points anymore, we're looking at the line that we drew. And they use the slope and y-intercept to write an equation that will help predict other things. So if we know what the line equation is, or close to what the line's equation is, we can use that line to predict for other pieces of our data. So getting down to some examples, identifying the best line of best fit. So below you guys have different scatter plots. Our example 1 says the scatter plots below show data comparison of the age a child and the cost of the birthday gift for that child. Which has the most accurate line of best fit? So between those three, A, B, or C, the one that fits the data the best is going to be C. So that is our answer. A, it goes kind of over top most of the points. B kind of goes below them. But C has that line kind of going through the middle. So that would be our line of best fit. The other two options, like we just said, are either too high or too low. And they seem to be trying to include outliers. So if we take a look at those pictures, these points would be considered outliers on our graphs, and we don't want to move our line based on those outliers. We do not consider those when we're trying to do our line of best fit. We just want it to fit mainly in the middle. Okay, go ahead and try the practice problem. Choose which one for each scatter plot. Tell which line of best fit is the most accurate. So for number 1, A, B, C, D, which one of those is most accurate? Go ahead and answer in the formative. Okay. Go ahead and do the same thing for questions 2 and 3, looking at A, B, C, and D. Which ones have the lines that are most accurate to the middle of the data? Go ahead and answer in your formative, 2 and 3. Okay, next we're going to talk about calculating the line of best fit. So as we can see, for example 2, it says to write an equation in slope-intercept form. Remember, that's y equals mx plus b for the line of best fit of the scatter plot. So for the first one, they've already given us the scatter plot and they've given us the line of best fit. So now we're just going to calculate the data or the slope. So remember that when we're finding slope, we want to find 2 points where we go through an x and y intersection. So I can use this point because it goes through that ordered pair, 3, 4. And then the next time it goes through an x and y intersection is right here. So all I'm going to do is count how far up it goes. 1, 2. And then how far over? 1, 2, 3. So that would be our slope. So we've just identified our slope from the line, which is our first step. And then we're going to identify the y-intercept on our coordinate plane. That would be 2. So our y-intercept is 2. So then we're going to go ahead and write our equation in slope-intercept form. So we've got our slope of 2/3, and we've got our y-intercept of 2. So that would be our equation for our line of best fit. Moving over to example 3, they did not give us the line. They did give us the scatter plot. So we're going to try to find the line of best fit for the scatter plot below. So we're going to try to get through most of our ordered pairs here. I can see that the middle of the data is around this area here. So looking at where that crosses the x or the y-axis, that's going to be at 9. So I can go ahead and eliminate answer choice C because the others do have the correct y-intercept. Now we're just going to calculate our slope and see which one has the most accurate slope. So I'm going to pick 2 ordered pairs on our line. And I've got this one goes through an x and y intersection, and then it looks like it goes through an x and y intersection right there. So it goes down 1, which gives me a negative slope, which automatically counts out B because that's a positive. And then we go right 2. So our slope should be -1/2. So that should give us answer choice D. So you guys go ahead and try the next 2 examples on your formative. 4, just like the one right above, they give you the line of best fit. And number 5, you have to draw it yourself. So go ahead and try those 2 on your own and answer in the formative.